Thank you so much for coming out in your evenings. First, I'll say a big thank you to Container Solutions for inviting me and hosting the event. Events like this don't really exist unless there are companies out there that are supporting them. So if you are interested in speaking at a Software Circus, you should have a chat to the organisers. I got started speaking at sort of corporate events internally inside my own company. Then I started doing public speaking at small user groups, much smaller than this, like 10 people in a pub. And so if you are interested in doing more like conference speaking yourself, then these are great places to come and, you know, share new material and get some practice. It's a mostly safe space. The other person I want to say thank you to is Trifork. I'm actually doing a 3-day training course as part of the Go-To Academy just down the road. So thank you as well to them. But we're here today to talk about microservices and more specifically, the interplay between microservice architectures and different types of organizational structures. And this is something that's always been lurking at the background of the conversations around microservices, but I think has often been overlooked in the sort of flurry of interest and activity around technology, right? As techies, we're in danger of sort of indulging in sort of this technical or technology fetishism. Okay, right now it's all about, it used to be about Docker, now it's Kubernetes, right? And so we sort of miss the point sometimes. And often how the organizational structures are set up is a real key part of whether or not we get the most out of these architectures. And that's what we're going to be exploring today. So they've talked about me. I run my own company. You can find out what I do on the internet. I do training and consulting work. I've also got a new book coming out, Monolith to Microservices. It should be out in the end of October. You can find more details over my website. This book's looking really at how do you take a monolithic system and break it apart. So there's loads of patterns for really nasty things like how do you break foreign key relationships in relational databases. So if that is your life, this is the book for you. If that is your life, I am also very sorry. But hopefully this book will kind of help. But we're here to talk about microservices. We always like microservices. Aren't they nice? Aren't they hexagonal? And I've been using the same definition for a while, these sort of independently deployable services that work together, modeled around a business domain. And really today's talk is more about this. It's this idea of independent deployability, although we'll touch on the domain-driven design side as well, and in terms of how that interplays with the organizational structures and what that sort of means. We talk about the concept of independent deployability. Actually, so more recently, I've been talking just more concretely about being independent releasability. So this is the idea that you can make a change to a service and you can deploy that service into production and release that functionality to your customers without having to deploy or release anything else. And so this is quite an important idea. We're trying to avoid patterns like the distributed monolith. So a distributed monolith is where you've got a distributed system, but the whole thing has to be deployed together. And those architectures tend to not really help deliver on the promises of being able to ship software more quickly or independent working. And so we're optimizing a lot of our choices around allowing work to be done in parallel and released on demand to our customers. And certainly I got interested in microservice architectures, or at least what we weren't calling them back microservice architectures back then, because I was focusing a lot on continuous delivery. So how do you make it easier to get software into the hands of your customers? And I often found it was the architecture that was one of the biggest inhibitors. And so I would argue that microservice architectures are kind of an architecture which is, I think Neil Ford says that microservices are the first post-DevOps architecture. And I can kind of see what he's going for. But I do wonder in a way if it's the first post-continuous delivery architecture. Although really microservices is just a bunch of really old ideas that we've kind of packaged together. And it's like JavaScript, the good bits, right? There's a lot of bad ideas. Well, there's a lot of ideas out there that don't work for how we build software nowadays. Once they're bad ideas, we just learn new things. So this idea of independent deployability is really key. It's how you get teams working in this sort of autonomous fashion. But that's not always what happens. Sometimes we have software architectures which don't allow us to do work quickly, don't allow us to make changes efficiently. We're going to take a look at what I'd consider to be more of a layered architecture. So we've decided, for whatever reason, we're going to take our architecture and we're going to break it down into layers. And layered architectures are often driven by sort of technical boundaries. We group like-minded technology functionality together into layers. This is a very simple kind of form of layered decomposition. We've got this is for a company that's selling CDs online. This is the fake company I've been using in my examples since 2012. You can tell I've been using it since 2012 because we sell compact discs online. So we've taken our monolith and we split it into two parts, right? We have the Music Corp's front-end website, which, of course, because we don't believe in this newfangled single-page app nonsense, what we're doing instead is we're just serving up HTML pages. And we're collecting the information in the state from our back-end persistence layer. If we want to change state, we have to make a call to the persistence layer and say, please persist this change. So it's very simple two-layered architecture. And obviously, as often is the case with these layered architectures, they're worked on by different groups of people, right? So we've got the front-end development team and a back-end development team. I've worked in so many organizations that have variations on this kind of layered style of architecture. Now, when we're thinking about these architectures, I don't like saying an architecture is bad or good. You've always got to put an architecture in the context of what it is you're trying to achieve. And often what happens is we build an architecture that was totally fit for purpose for how we did things. And now, what we want to do with that system has changed. And so the idea that our architecture is now bad, it's not. It's just not fit for what we want to do with it today. Now, if you think about what we were, when I first started as a consultant in 2004, most of my customers were shipping software every year to every 18 months. That was the normal release cadence for software, was every 12 months to 18 months. How many people here work on systems where they ship software to production more than once a month? Anyone put your hands up? How about more than once a week? How about more than multiple times per week? Maybe more times a day? Yeah, okay. If I'd said those, say, oh, you can release software multiple times per day to people in 2004, I would have been laughed out of the room, even though there were people doing it in isolation. So when you start looking at architectures like this, that are kind of these architectures are being passed down to us and ways of working, and we start to look at it through those lenses, they start to cause us challenges. So we're going to make a change, a very simple change in functionality. We're going to give you the ability to specify your favorite genre of music, and that's all you have to do. So you're going to go and select from a drop-down box. My favorite genre of music is death polka. Right, so death polka is a mashup of death metal and polka music. I thought I had made that music up, but I should have remembered the variation of Rule 43. Basically, it does exist. I was doing a workshop in Stavanger, and one of the participants in the workshop played me some death polka, and I wish I'd never heard it in my life. But nonetheless, right, so it's a big drop-down box. Now, to show that drop-down field, we're going to have to fetch the list of available genres from our back-end persistence layer. These are going to be our options that are going to be in the database, right? So we're going to make a service call to pull back that list of genres. We're then going to have to create a GUI control and present that to the customer. And they're going to make a change and say, I like death polka, and click OK. We then need to save that change again back in that persistence layer. And so, I mean, look, let's be honest, a lot of our jobs are like this. I mean, I always imagine that 75% of my career has been taking data out of a database and putting it on a screen. And when I'm very lucky, the other 25% of my career has been taking data off a screen and putting it back in a database, right? That's most of what we do. And this is a very simple example, a very simple, small change in functionality that cuts across and requires changes in two different places. I now need to have to expose new methods here to support functionality here. I'm now going to have to coordinate effort and activity across two teams. I'm either going to say, let's release the software at the same time. Let's all go live at once. And then we've got a big bang release. We don't like that. Or we're going to phase deployments. We're going to deploy this thing first, then this thing first, right? So if, in terms of making it easy to make changes, this doesn't feel right. What this is optimized for is if I just want to make changes in the persistence layer. Great, those are fast and efficient. How often do you get features that require you just to make changes to the data layer or just to make changes to the UI layer? It doesn't really happen. And this is obviously a simple example of a layered architecture. I've worked with much more complex examples. But they all have this problem where they have low cohesion of business functionality. The business functionality is sort of smeared across the layers. And if you look at Constantine's law, which comes out of structured programming, way back in I suppose, Constantine's law, I think it was about 1969, where some of you were still alive, we know that when we have low cohesion, you have high coupling. That's the other end of the spectrum. So you end up with layers that are now tightly coupled to each other. Isn't that fun? We all like that, don't we? And these things can get worse. I worked for a short period of time with a ticketing company based here in Europe for transport ticketing. And they had a very heavily layered architecture. And they were suffering from an extremely slow pace of change. It was taking a long time to get anything done. One of the consultants working there was an independent consultant. He basically done a really good bit of analysis. Who here is a really big fan of Jira? We've got 3 people, 4 people. Okay, sorry, that's the wrong question. Who here is made to use Jira as part of their day job? Yeah, that's the other question, right? I've come to believe it's not Jira's fault. I just don't think we enjoy that part of our job. I think it's very hard to have a story tracking system that brings delight, because that's the bookkeeping part of our job. But one of the great things you can do with a tool like Jira is you can associate commits with stories. And not a lot of people do this, but it can be incredibly useful. So what this consultant had done was he'd taken a look at all the commits that were done and basically mapped those, so a story to how many services needed to be changed in that services stack. And he found that on average, each story required about 6 services to be changed. So this particular architecture, there were 60 services. There were 80 developers working on this project. They were pairing, so effectively 40 developer pairs. They were shipping software on 2 weekly cycles, but they were quite slow changes. They weren't getting much done. Each dev pair would maybe get 1 story done an iteration. So on average, you had 40 stories being done per iteration. On average, each story affects 6 services. So guess what? Turns out that virtually most services got changed every single sprint. So what does that mean? Well, it's released the whole thing together every single sprint. So the problem with the release train, right? The release train kind of binds you into releasing all your software in one big bell swoop. Release trains lead to distributed monoliths as well, which is another reason why SAFe has problems. So I call these architectures that are very, very highly layered, I call them onion architectures, right? Because they've got loads and loads of layers, and if you have to slice through them all, they're going to make you cry, right? So this is the problem. Now, there are reasons these architectures spring up. I'm not so sure about that really highly layered one we found, but these types of layered architectures, there are reasons why they happen. Although they don't necessarily seem to be suitable for our desires nowadays to ship software more quickly, we still have to understand why they occurred in the first place. Here we go, one of the most famous examples of your layered architecture, the 3-tiered architecture. I think there's kind of 2 reasons we see this so often. The first is it's totally universal. As technologists, we can have conversations with other techies from different domains about this architecture. And we get to pretend that the domain what we're building software for doesn't matter. Oh yeah, because technology is not really about people and politics and social issues, which is such a giant amount of, it's just going out horseshit. We can bleep that in the video, right? It is, right? You can't take software away from the context which it operates, but we like to pretend we can. And this is one way of doing it. Look, it doesn't matter what it is. Is it a nuclear power station? Could be. Are we doing the irrigation system for a garden centre? Maybe we are. What about selling CDs online? That's okay. Let me get out my 3-tiered architecture rubber stamp. I'll put it up on the wall. There we go. I'll sign that. We'll laminate that. And there's your architecture diagram. You don't have to think about that ever again. And there is something about having a universal architecture that you can pretend is generally applicable everywhere. It doesn't actually necessarily help us be productive, right? There's another bigger reason, though, a much bigger reason I've come to realize why this architecture is so universal. And it comes back to how we organize ourselves. Because again, what happens with these layers? They're owned by different teams. We have the front-end developers, don't we? We all know who the front-end developers are because they've got funky haircuts, they probably drive fixed-wheel bikes, and they know where the best coffee shops are, and they've probably got lots of tattoos, right? We've then got the business developers who tend to, they'll wear a shirt tucked in, but no tie, and we'll all wear, we'll all carry around copies of Martin Faller's hardback books. I've got all of Martin's books. He writes really, really well, right? But that's that. That's a stereotype. And here, of course, we're Java and C# developers. Node. We're going to use JavaScript. And then on the database side, of course, we've got the DBAs. and no one's quite sure where the DBAs are. But the database still works. They must be here somewhere. We're in the basement. We don't need any fresh light. We roll food down to them. We roll some bitterballen down to them at the end of every week, right? And this is all stereotypical stuff because it's a bit of tribalism in there, right? I'm being purposefully provocative in a way because there is a bit of tribalism. We tend to denigrate people who have skill sets that we don't have or don't understand. Again, there's a whole contempt culture line here. But this is also because of how organizations group themselves. The traditional way of organizing people in IT is based on your core competency. You are identified as I am a JavaScript developer, so I do front-end development, and I am in a team with other front-end developers. I am a Java developer, so I'm in a team with other Java developers. I'm a DBA, so I'm in a team with other DBAs. It's basically Taylorism, right? This is all about creating organizational structures that are optimized for utilization, not throughput. So this is the organization ends up driving the architecture. Now, of course, this way of thinking is falling out of favor fast because we realize that if you have to hand off things between teams, it slows you down. This is just fundamental queuing theory. Cut away all the other bullshit around Agile. Reduce handoffs, you go faster, right? Reducing the handoffs is the hard part, but that's what it is about, right? And if we have to hand off between these things to get work done, it will make you slower. Because this is what our old school organizational structure looked like as well, wasn't it, right? All the developers, you'd have a head of engineering, you'd have a head of the test, you'd have a head DBA, you'd have a head of infrastructure, and then they would report up to your CIO or your CTO. There'd be this yawning chasm of distrust into the business. No one was quite sure who the business were. You thought they might be into organized crime or something, the way they were described, but this is the problem. This is old school IT, though, because we've recognized the value of removing handoffs between this and being more focused on the end-to-end delivery of software. This should not come as a surprise to any of you. Melvin Conway kind of made this observation back in the mid-60s. This became known as Conway's Law. Organizations that create software end up creating software and the architecture of that software just basically follows the organizational communication structures. How your organization communicates drives the system architecture. This has actually been proved out. There's been a whole bunch of really interesting studies that actually have proved out that this is absolutely observable, aside from the overwhelming bulk of anecdotal evidence. There's been great studies by Microsoft, amongst others, show that this happens in practice. And so you group yourself, and that drives your architecture. You can try and fight against that, but it can be difficult. So if this is your architecture, one of the ways you might try and deal with those problems of slower pace of delivery because of handoffs is say, we're going to reduce the handoffs. So what we're going to do is we're going to create a poly-skilled team, not a full-stack team. Charity Majors says you're not full stack unless you're designing your own chips, right? So let's get rid of that idea. A poly-skilled team, you get a group of people together that are going to own the end-to-end delivery of some user-facing functionality. That poly-skilled team contains all the skills needed to get that job done. You might be incredibly fortunate and have one of those unicorn people that can really do excellent front-end development and is a great distributed systems engineer and can also optimize a query plan. If you've got those people, great. But more likely, you've got some people that have specialisms in certain areas, and you get them working together as, a team. And they then, what was called a feature-based team. And so you would work together to make all the changes you need to in the places you need to. You collaborate, and you have, okay, I'm going to make this change, you make that change there, and you're on the same page. You're coordinating. The challenge is when you overlay these sorts of end-to-end slices on top of this architecture, is the architecture is sort of fighting you a bit. We want to make a change here, but the problem is there's another feature-based team in the same space, and they want to make a different change that gets in our way. This team over here is ready to go live with their front-end changes, but this team here is still behind in there, and they don't want that to go live yet. And so you end up with all these sources of contention in that architecture. And this can be made even worse in organizations where you effectively have matrix ownership, which is like where you still also got some teams working at right angles to you. And this there just ends up in huge amounts of sort of butting of heads. I call it sort of contention. Another word for this is the need for coordination. I've got some water over there in my bottle. If I went around every single one of you and said, can I drink this water? I hope you'd all say, yes, you can drink that water. But by the time you'd all got back to me, I would probably have died of thirst. It's unlikely, but it might happen, right? When you coordinate with people, by necessity, it will slow you down because you have to wait for the confirmation. That's what coordination is about. Should we do this? Agreement. That takes time. There are good reasons to do that, and there are other places where trying to agree and coordinate with people will slow you down. Having to get 10 different teams releasing software on the same day at the same time, those sorts of release coordination activities, they're not fun. There's a lot more that can go wrong. So these end-to-end slices, though, show us a different path. When we talk about collective sort of feature-based teams, we've got a team that can make changes wherever they've got to make changes. That tends to drive us towards kind of what we talk about as collective ownership models. A collective ownership model is where anyone can change anything. There's some nuance here that we need to explore. We're going to come back to this idea a bit later on. But the core idea is, with a microservice architecture, we're sort of saying we're going to embrace those end-to-end slices. That end-to-end slice of functionality is what we want. But rather than it being kind of overlaid onto a horizontally sliced system, we're instead going to take out our problem space and slice it vertically. And inside each vertical slice, which is focused around a subset of our business functionality, inside that slice, we may well be reproducing these 3 layers. But what we're doing is we're choosing business functionality, our domain functionality as our unit of cohesion, not our technology. Right? Because actually changes tend to be a change in business functionality, not a change all database code everywhere type operation. We're aiming for a change only impacting a small number of services. And in fact, when you're moving to a microservice architecture, this is an important thing you can track. How often is it that you're having to change multiple services at once to roll out a piece of functionality? Is that a problem? Every now and then it will happen. But if it's the norm, your architectures might be sliced up in the wrong places, or maybe your features are sliced up in the wrong way. It should be the exception. That's what we're looking for. On the ownership models, it's probably worth reflecting on these terms. The terms like collective ownership gets used a lot in the context of microservices, but it's worth going back to the original definition. So Martin wrote this up back in 2006, and he tried to articulate the different sort of ownership models. Now, the key thing to understand here is this is before GitHub was being used. This is really before Git. Well, Git was around in 2006, not in a form that anyone was using. So this was before a lot of those things were being done. So Martin talks about strong, weak, and collective ownership. Strong ownership is where a group of people own something, and those are the people that can change that thing. This is mine. We are responsible for it, and that word responsible is very important. If you want to make changes to this thing that is mine, you have to ask me. That is internal open source, by the way. That is actually most open source development is strong. You have a small number of core committers that have commit rights to the project. They vet pull requests. That is actually strong ownership. Collective ownership is where you say, look, anybody that's in this organization can change anything they want. It does work in some places. It doesn't tend to scale very well. And those are kind of the ends of the spectrum. So if we talk about how those ideas might apply to services, here we are. We've got 3 teams, and we've got 6 services. So how would we map them? So with a collective ownership model, all those 3 teams can make changes whenever required in any one of those 6 services. They can go wherever they want to make changes wherever they like. One of the nice things about this kind of model is it gives you a lot of flexibility about where you put your people. Right? You can work wherever you need to. If we need a load of changes being made in the inventory server, we'll just add more people to that part of the project. So you can kind of have that storming model to get things done. There's a couple of challenges, though. As the scope of this thing grows, or the number of people grows, it can be difficult to really be aligned about what is a good change in this system. How is the inventory service moving forward? Do we have someone that's focused enough on that problem space to be thinking about what makes for a good change? If you're just sort of skipping from one service to another, who's ever there and spending enough time with that to say, actually, there's some weird things happening in this space. We need to kind of adjust it. The other issue as well is certainly with complicated domains is if you're skipping across these services, you're also skipping from one part of the business domain to another. And so retaining alignment between team structure and maybe your product delivery structure might be different. And that's that's again a kind of a shift that's happening. Well, if you're looking at the smarter technology companies, now what you're seeing is rather than having a siloed IT organization, you have the product owner that's in charge of that part of the delivery, and the developers work very closely, kind of aligned with the product owner. The product owner is part of that team, in fact. And so not having good alignment to the business domain here, because effectively you're aligned to the entire domain. Again, this is a size issue. This is manageable with like 20 people, especially if they're co-located. It doesn't work so well when you've got 200 or 2,000. This stuff becomes much, much harder to deal with. So the other option is kind of more of a strong ownership. This is where you can map a service to a team that owns that service. So in this situation here, this team here owns both the shipping and the user service. That is their responsibility. They are accountable for that service. They make changes to it. They also describe what a good change looks like. If you want to make a change to that service, you come and ask them. And again, this could be a pull request type model. A pull request model is a bit more effective than raising a ticket, for example. So you have very, very clear lines of ownership. It's also very, very clear lines of responsibility. One of the nice models here is you can actually say, this is yours, you are responsible for it. That can be a great way for people to feel empowered and to grow new skills. It can also be scary because there's the other word that comes with this. It's accountable. You're now responsible for this. That's a scary word, right? Likewise, you can also have increased autonomy. You can afford to make changes locally within the services that you own that might be different to other people's changes because you sort of see the benefit and the impact of that. If you make a decision to code these in a functional style because that's what makes sense to your team, that might make your team more effective and efficient. That might not be a decision you could make, though, if you needed to have a degree of consistency across your entire architecture. It does, though, cause some issues. Alignment to the business here is trivial, well, by comparison. Some of the issues it causes around things like bottlenecks. What happens now if this team is slammed? How do we solve that problem? We also have an issue around orphan services. And this is more problematic with these strong ownership models. With a collective ownership model, there is the idea that the organization is set up that anyone can go wherever they need to make a change. And so in that environment, it's like, well, an orphan service, there isn't such a thing because everything's really owned anyway, conceptually. Although I'd argue even then it does happen. With strong ownership, though, there is a higher chance that a service might be orphaned because everyone thinks that somebody else owned it and that team no longer exists. So we'll talk about some models of how you fix those things. We also have to talk about the global versus local optimization problem as well. And this is that kind of problem underneath the autonomy. I give teams autonomy and give them responsibility to vary how they do things in their team. What does that do to me across the entire organization? Fundamentally, like collective code ownership, I don't think scales very well. Collective ownership of code certainly doesn't scale very well. Within a single team, absolutely. Within 10 people, sure, if you can't practice collective ownership within a team of 10 people, there's probably something wrong with your team. But as you add people or distribution, this becomes increasingly problematic. You can kind of think of these things in a bit of a spectrum, right? With collective ownership, you're going to tend towards more global consistency because you need things to be familiar. If I work on this service, I need to be able to go and work on that service, and there should be some commonality. Same programming language, same programming idioms, similar technology choices. As I come over this side, with strong ownership, I'm allowing for more local optimization. You can pick the right tool for the right job, and that's okay, because that's a local decision you're allowed to make. The key thing to understand about this, of course, is this is not an either or, this is a spectrum. And you can actually decide where you want to be on this spectrum. I think, you might be right over here. If you've got like 5 people, firstly, you shouldn't be doing microservices, but 5 people, you probably want to do a good consistency. You're 500, and you want to go fast, maybe much more over here. Let's take a look at an example of a company that does maybe focus on local optimization and what that means. A company like Amazon. Amazon, of course, are often the poster children for sort of the things like the 2-pizza team. right? This idea of autonomous teams that can own the end-to-end delivery of products, and that they should be so small enough that they could be fed by 2 pizzas. It's never really defined if those 2 pizzas are feeding them for lunch or dinner, or how big the pizzas are, if they're American pizzas or Italian pizzas or Chicago pizzas, which could probably feed a small town for several weeks. But nonetheless, there is this idea that very early on, Amazon wanted to have these autonomous units that were able to own the end-to-end delivery of product. And there's a reason why, as an example, AWS outcompetes its rivals in terms of delivery of product set. Way more features, way more products than anybody else, and those products are owned by different teams. The problem with that is it can sometimes lead to things being disjointed. So 2 years ago at reInvent, Amazon announced that they were doing managed Kubernetes. So managed Kubernetes was the least well-kept secret in the cloud space. Of course, Amazon were going to do managed Kubernetes. It was a question of when, not if. They also announced Fargate. What was it, Farscape? One is the sci-fi series, Fargate, right? Which is the per second price container service. So Kubernetes, a system for running containers. Fargate, per second price containers. Of course these ideas would work together, all know. Someone says, so when are these 2 things going to work together? They say, oh, we're looking into that. It's an obvious thing that these solutions should be joined up. Absolutely not, because they're developed by different people in parallel, and arguably they're competing for the same customers. Now, Amazon, as a trade-off, they accept that they're going to have disjointed products sometimes as a result. The flip side is they get product out there more quickly, and that's their competitive edge. Some of the other cloud vendors might have a slower pace of change, partly because they're trying to make sure these things stitch together. Another great example, SQS was released in 2006, was the queue service. Lambda was released in 2014. That's the ability to run a function when an event happens. It took another 4 years before you could put something in SQS and have it trigger a Lambda function. Right? So these are trade-offs. Just go fast and just ship product. But you've got to stitch it together again. So that's an example of Amazon who is sort of focused very much on local optimization within those product teams. And that's part of what they view as their corporate strategy. And you might want to put that level in a different place if you're a different type of organization. So coming back to these problems of defined ownership boundaries, or sort of strong ownership boundaries, and this is by far the most prevalent model. Most microservice organizations that are operating at any scale end up mostly having this sort of model, a concept of strong ownership. The majority of services are owned by a team. That team is responsible for them. And maybe overlaid on top of that, you have some kind of internal open source model. There are absolutely exceptions to the rule because there are always exceptions to the rule. Mondo in the UK, for example, have 800 services and apparently a fully collective ownership model. It's clearly all made up because they do all the things I say you shouldn't do, and they claim to have a successful business. So somewhere along the lines, they're clearly lying to me about what's happening. I am going to try and find out how they make it work. But most organizations end up looking like this. But then the question is, well, how do we deal with these sorts of issues? The bottleneck one is kind of one of the most pressing. So I've got loads of work that the customer service team needs to build up, right? And they are under the pump. They've got so much stuff they've got to work on. And they said, look, we can get to your things, but it's going to take us a few months. Well, that's too long. That's too long. So what can we do? How can we solve that problem? Well, one option is just to, move people. We need to add more people to the team. Can we throw people at the problem? Up to a certain point, we know we can. Ish. I mean, obviously, you've all read The Mythical Man Month. How many people have read The Mythical Man Month? How many people really read? Okay, the rest of you with your hands not up should read that book. It's only about 30 years old now, and it's still essential reading for software development. But there are diminishing returns, but to an extent, you can. You could just second people for a couple of weeks, go work with them. If I want you to make a change to your service, why don't I come and join your team and make that change with you? Now, for that to work, of course, there's an issue about how much these might vary. If I've decided to write this service in C# and this service is written in Ruby, am I going to be productive in that environment? And that's why some organizations don't allow a free-for-all in terms of programming languages, so it gives them flexibility of moving people around. It's a valid choice to make. What else could we do? Pull request model. Okay, so I make a change and I send it over. So this is an internal open source model. Now, having an internal open source model doesn't mean I've got GitHub Enterprise. Okay? Any more than having a CI server means you're actually doing CI. For you to properly and embrace an internal open source model like this, it is part of your responsibility as the owner of a service to make it easy for people to submit pull requests. And that means good documentation, making it easy to build and run tests. And also it's part of your job and your responsibility to actually deal with those requests when they come in. And actually build that. This is like a product. It's like product development almost in a way. So this is something that a lot of scale-ups often struggle with. I was working with a scale-up recently who were, one of the key metrics we were sort of evaluating was actually each team would have a KPI around the pull requests they had coming in. So they'd be able to say, here's how many pull requests are coming in, here's how long they're open for, we close them this quickly. And it was not about saying our team's better than yours, it was more about each team understanding the trends in their own space. And actually in a couple of cases, I saw teams looking at these pull requests and realizing actually that was going to change how they develop their software. They're actually kind of moving to more pluggable models where actually teams could contribute in a library for their own customized functionality. So you have to go more. Internal open source is just like external open source. Just because your project's on Git doesn't mean it's any good, right? So a couple of models there. Second problem is orphan services. This gets problematic. We were working and we spun up a team to work on some stuff. And it's often the case with microservice architectures, once you've got it working and it's kind of small and focused and does one thing and does it well, it does one thing and does it well. And it might not need to be changed for weeks, months, maybe even into years. And suddenly, before you know it, all the people that worked on the customer service have scattered to the four winds. Some have left the organization. Some have moved around. But you suddenly look around and realize, hang on, who owns this? And the kind of answer is, well, somebody has to. But I've heard all kinds of horror stories, like, we don't know what it is, but we know we use it. We don't know where the source code is. That's scary. Please put your code in source control. That shouldn't be hard to say. Lots of organizations, again, those sort of when they're getting to those larger sizes, are actually building internal service catalogs to solve this problem. So the Financial Times, for example, have got their BizOps system. So Sarah Wells did a really great keynote at QCon London earlier this year talking about the BizOps systems they build there to help track ownership and the concept of ownership. So here these people have all scattered to the four winds and they're all off. So how do we solve this problem? We want to make a change. How do we make a change? Well, the first thing to say is, well, actually, it's got to have an owner. So if you want to change it, you touched it last, it's now yours. Take ownership. Get an admin to give you commit rights. That's now your responsibility. You can do whatever you want with it now. So actually, you find that in organizations that previously were developers, I want to own stuff, and then you start giving them stuff to own. They're like, I don't really want to own anything. Can I give it back? He's like, no, it's yours. You touched it last, right? But this could be hard process, but maybe it's the right thing. Somebody has to own it. You have to know who's in charge of this thing. You know, obviously, a small team, be collective, fine. Other options is sort of the roving custodian model. And again, this is a bit like the open source world. What you do is you say, well, this service doesn't actually have a team anymore. It doesn't have a concrete team. It has maybe more of a virtual team. There is no kind of product area where this is falls, but we have got is 6 or 7 people, or 2 or 3 people that know that service really well. And they're in different places now, but they still own commit rights. So they're like the core committers. You go find them and say, can we make a change? That model can work really, really well. So it's still, you have your ownership then is sort of not, is a dotted line rather than being your firm team boundaries. And so that roving custodian model is highly effective. It's actually interesting if you look at the people who use mono-repos effectively, which are not many people, but in those situations, they all have very fine-grained ownership concepts that allow you to do things like this. Every single, like the Google mono-repo, for example, every single directory has an owner's file. The owner's file says who owns the code in that location. That's every single directory, and even in a hierarchical sense. So, okay, I'm going to find you, come help me out. The other problem that's really tricky, and this is what many of my enterprise clients really struggle with, is the global versus local optimization problem. And that's more prevalent where you have strong concepts of ownership. So The team over here who are looking after shipping have decided they need to be web scale, and so they picked Mongo, right? It's very important that they're web scale, so they've got Mongo. The customer service team have got bigger problems to worry about, and they've already got a database and it works, they can stick with Oracle. And the return service have thought, well, we need to massively scale up writes, because it turns out that no one likes these CDs anymore, and they keep sending them back. So we need a massively write scalable system, so we're going to adopt Cassandra. And you've empowered those teams to make these decisions for themselves. And you look at each decision they've made, and you say, you know what, I can, just by looking at your viewpoint, every single one of those decisions was totally rational. That was a call. I can totally understand why you made that choice. But you also need sometimes in these situations to step back and go, well, every choice that was made here at a local level makes perfect sense. Taken across the whole, does it make sense for us to have to support 3 different types of database technology in our organization? Potentially 3 different sets of vendors. These databases have to be run, managed, backed up, have to be resilient, right? I have to know how to spin these things up in test environments. And that might be where I want to spend my time, or it might not be. The key thing is, if you don't know this is happening, you don't even get to make the choice. The answer might actually be to say, well, look, as a compromise, why don't we all standardize on Oracle? Because it's no one's favorite, but it's good enough. Maybe Oracle's a bad example in this situation, but it's definitely nice. But, this is why Netflix, for example, standardizes on Cassandra. So for a very long time, if your default way of storing data was in Cassandra. And they said, look, it's not perfect for every job, but it's good enough for 90% of the jobs we do. And we've got really good at making Cassandra incredibly easy to use in Netflix. So a valid set of trade-offs that you can make. The key thing, again, is that you've got levers to play with. But unless you know that these things are happening inside your organization, you don't get to play with those levers. And this is why it's important that although your primary unit of ownership and organizational structure should be around your business domain, we have lost some of the cross-cutting technical oversight. When we had siloed IT, all we had was cross-cutting IT oversight. And that was kind of not right. And now we're going to, business-oriented sort of product development teams. We're much more focused on parts of our business domain. We still do want some IT alignment across the piece. It might be quite a light touch. This might be something as simple as a community of practice. This might just be, do these people have a place where they can go, hey, I'm thinking of using a database, what do you think? Or it might need to be something more enforced, maybe some kind of governance organization that sits across the piece here, that's trying to stitch this stuff together. If you've got concerns, if you want a bit more flexibility in terms of how you move people around, even though you might embrace a strong ownership, you might want a bit more consistency. And again, when you look at those organizations that do operate at large scale with microservice architectures, yes, they do have lots of technology. No, they don't have all the technology in the world. So I worked at Google for almost a couple of years, and at that time, there were 4 blessed languages. You could use JavaScript, which is only really got used in the browser. At that time, you could use Python, C++, or Java. If you picked any one of those languages, no one would ever ask you a question about why you're doing it. And you would also have a really good development environment and some excellent supporting libraries. And you basically had a paved path and things were really, really easy. If you stepped outside of that world, things got tricky and you had to justify your decision. Netflix made the decision that all communication over remote networks would be between JVM-based processes. And that was primarily because they'd invested a lot of time and energy in creating libraries and shared code that allowed for sort of efficient and robust communication for synchronous calls between services. And they said they knew that worked. And so they said, it's JVM to JVM because we know that works. You get to choose what kind of company you are. You might want a degree of consistency for good reasons, as long as it's rooted in a decision about your tech strategy and you take account of that. There's still lots of things you can do around the edges here. So this problem of local versus global optimization is sort of a challenge. What microservice architectures do is they give you a whole host of options that you did not have before. And that can lead you to have a lot more flexibility in how you group and organize yourselves. I don't think you should throw the whole organization away and start again, right? But you can tweak it. You can change it. You have more levers than you ever had before, but you need to be in charge of those levers. Things like global versus local optimization before become really, really important to understand. A lot of scale-ups actually just let this go. They focus on local optimization because their focus is market share product. And they understand that in doing so, they will create a high degree potentially of inefficiency and duplication of effort. But if you're growing fast, that might still be the right thing. A lot of scale-ups get to that point when they suddenly realize, oh, hang on a minute, maybe now's the time to have some consistency so we get a bit more efficient at how we do things. This is a natural process in any organization growing. And that goes for products inside existing companies. There'll be times when you just want to go fast and just get stuff done, and then maybe later on you change. This balancing force will shift at different stages of your organization. So microservices are an architecture which really optimizes for autonomy. So autonomy, distributing responsibility. You have to decide how much autonomy you want with these things. Okay, that's a choice for you. And just remember, the more you trend towards fully collective ownership, when anyone can change anything, the more you're going to probably also have to accept a higher degree of global consistency. The more you're okay with strong ownership and the downsides, the more you're going to get the options for local optimization. Anyway, I hope this was useful. This is being recorded, so it'll be available on the internets. There's an early version of this talk available online. I've got loads of other talks actually available over my website. They're all available for free. So pretty much all the talks I've done for the last 10 years are available for free to watch on YouTube. If you're a glutton for punishment, there's a good 15 hours of content there. I mean, that's going to be a depressing day, you know. Take a break, right? And there's links and information about my new book as well. So thank you very much indeed. Do you trust male engineers without beards?
Let's start with this one.
I mean, I don't judge people based on appearance, he says, knowing that's a total lie because we all have biases. Yeah, it's a bit of a beardy time at the moment. I've had this beard since I was 20, and this is not a new look. It's because I was a student and I was lazy. And I realized I could go about 4 weeks before having to deal with this situation, whereas shaving required effort every single day. My wife now tells me if I shave my beard off, she'll leave me. So I've got another reason to keep the beard. Okay, next edition of the book. So I'm working on a second edition of Building Microservices. If you have read Building Microservices and have thoughts or of feedback about what you would like to see in the second edition, let me know. It won't be out till next year, probably this time next year, the absolute earliest. I know there are some incorrect release dates out there because don't know why. Apologies for that. How to convince the management and people resistant to change to use microservices. So, okay, good question. I get it a lot. Why should they give a crap? I mean, seriously, right? Why should they give a crap? People who use your software should not care how it's implemented. It should just do the job. So as techies, we become fascinated with the technical detail of how our things are built. It doesn't matter that much if it doesn't work. I don't care if it's written in C or Rust or Go or Ruby or PHP. If it's an awesome product, it's an awesome product. So if you're trying to talk to people that are not techies about why they should use microservices, why would they care about that? You've got to sell it to them. A microservice architecture, it should not be a default choice. Absolutely should not, right? A microservice architecture is an option you have around an architecture. And you should be adopting it because this is going to help you do things that you can't do today with your existing architecture. So the question is, what are the problems that you're facing today that your current architecture doesn't work for? And then talk about those issues. If the people that need to make the decisions don't share your view of the challenges, they're not going to be on board for the solution you're proposing. So if your manager is really worried about the fact that your product's a massive success but you can't scale the system, then maybe microservices are the way to solve that scaling problem. Then you don't say, let's do microservices, because they're going to go, oh God, yet another flash-in-the-pan buzzword that's going to cost me money. What you say to them is, I think I know how to solve the scaling problem. Then they get interested. Now, of course, you've got to be honest with yourself. If your goal is to solve the scaling problem, Think of the other things you could do to solve the scaling problems, like, for example, have 20 copies of your monolith. That's a lot cheaper and quicker to try out than have a microservice architecture. So focus on the goal. Focus on the things you can't do today with your architecture that you need to be able to do, and then talk about those changes that you're going to bring about. Okay. Are there still valid cases, use cases of monoliths? I would turn that around and say, I mean, a monolith is my default choice for architecture. So I would spin that around. I think you'd ask, where would you use a microservice architecture? So absolutely. Let's be really clear. There are plenty of organizations that have been incredibly successful on the back of monolithic software. Salesforce is a 20-year-old company with a market capitalization of $60 billion. The vast majority of that was based on a 15-year-old Java monolith. We could talk about Flickr, we could talk about Etsy, we could talk about Facebook, which is still a mostly monolithic PHP application. Okay, so this idea that monoliths are universally bad is a problem. What people have done over the last few years is they've replaced the word legacy with the word monolith. The reality is actually, if we were better at creating modules, these are quite new ideas, they've only been with us since the late 60s. If we could create proper modular monolithic software, a lot of people would not need microservice architectures. There are definitely some problem spaces where microservices are incredibly effective and efficient. But for many people, all that's really happening is that network boundary is forcing you to think carefully around modular decomposition. And we didn't do that inside our monoliths. So I would spin that around. Any advice about versioning of interface contracts? This is always how the question is phrased. The versioning side is actually the least interesting part, like semantic versus whole number. The more interesting thing is breaking changes. In general, with services, you've got to think about the cost of change of breakage. If you're using services that talk to each other and a team owns all of those services together, it's much easier to manage that contract change. You may not need any form of versioning whatsoever. If I'm exposing services to other teams, I have to be much more mature about how I make changes to those services. So first thing, do you know clearly when you're making a backwards incompatible change to services? One of the biggest things that trip companies up early on is they fall into this pattern of making accidental breaking changes to software. So they make a change, deploy it to production, and things don't work anymore. Okay? That's just maturity and being sensible. A lot of the issue is often because you don't separate, again, this is modular decomposition, you don't separate the contract that your service exposes from internal implementation detail. If you have clear separation, make it hard to make changes to your service contract. Right? Have developers go out of their way to make those changes, and it'll be much more of a conscious thing. Eliminate accidental breakages straight away. And some things, like schemas, can be highly effective at helping catch some of those things. We've got rid of schemas because everyone went, oh, XML's bad, let's go for JSON. Guess what? We don't use schemas with JSON. So schemas are useful. So eliminate accidental breakages. If you make a change to a contract that's backwards compatible, who cares? Move on with your life. Breaking changes, there are ways of solving this. Probably the easiest way to handle this is to remember that conceptually, a microservice can expose more than one networked endpoint. If I'm going to make a backwards incompatible change, what I don't want is to have enforce a lockstep release. So I'm going live on Tuesday, and I've got a new version of my protocol, and you've got to use my you're a consumer of my old service. I'm going live on Tuesday, I'm going to break your service. So you better get ready to use my new API. Oh, it's not ready yet, but it'll be ready on Tuesday. So you ready to go live on the same day? Right, it's Tuesday. You ready? 1, 2, 3, deploy. And of course, that gets worse if you've got like loads of services. So we hate that. That's a terrible idea. So what you want to do is you want to roll out the backwards incompatible sort of contract alongside the old version of that contract, because that then gives all of your consumers time to upgrade. And how long you give them is kind of a social construct in a way. The harder it is for your consumers to change, that longer you're going to have to coexist them for. So then the easiest way to handle that, a microservice can expose more than one networked endpoint. So have a microservice expose both the old API and the new API from the same piece of code. It greatly simplifies this problem. And so there's no reason why a service can't expose a version 1 API and a version 2 API and a version 3 API all within the same code base. You still have consistency of data across those service instances. It's a really common solution to this problem. But schemas as well. So my same are collective ownership. I think collective ownership, so everyone can own all the code, works really well for a small number of people. So if you're going to have a monorepo, where so a monorepo is where all the code for all your services is in one place. That model works well if you don't want to apply any ownership controls for small numbers of people. 5, 10, 15, 20 people, absolutely fine. Beyond that, monorepos tend to atrophy. The people who use monorepos at scale overlay on top of that fine-grained ownership concepts. The owners files I talked about earlier that Google make heavy use of. There's a great ACM piece actually all about how the Google monorepo works. And that's often the problem. A lot of people that adopt a monorepo miss that ownership part. There's another potential problem with a monorepo, especially in the context of a microservice architecture. A lot of people pick a monorepo because they say, I want to be able to apply atomic changes across lots of services at once. We're not trying to encourage making atomic changes across lots of services at once. You can't deploy those in an atomic fashion. Why are you refactoring this more across those services? You often find in organizations that are doing a lot of this that actually you're ending up with coupled service contracts as a result. So it doesn't always happen. It is something to be wary of. So if you're going to use a monorepo at scale, apply tight ownership controls. Be extremely careful about the implications of coupling changes. The third thing I'd say is that builds get really complicated really fast. There's a reason that when I was at Google, I was in the 200-person tool team that looked after the Google build chain. So they use a graph-based build tool to work out the reverse dependencies of any files you change, to work out which bits of code need to compile. Because it's not as simple as saying when something changes, think about it, you've got effectively a big giant repo. When something changes, what do I build? Do I run the whole thing? So with a large monorepo at scale, I'm now having to run everything. So your compilation times go through the roof. So that's why you see things like Bazel and Buck, which are graph-based open source build systems that support monorepos at scale. So if your monorepo grows to a sufficient scale, you're likely going to have to change your build chain as well. So again, small scale, not a problem at all. Large scale, you've got to apply that thinking. That's why I personally feel that the multi-repo approach in general tends to be easier. It sort of makes it harder for you to make cross-cutting changes, simpler build cycles, you can use your old tools. Again, if you're Google or Facebook, you can afford to have lots of people making those tool chains work really effectively for you. Okay.
So go from the top one.
I'm going, okay. Oh, you're voting. Oh, it's democracy. Yeah. We tried that in the UK. Okay, so how do you manage event-driven communication between microservices, brackets with different owners? That's from Marco. So I'm not quite sure what you mean by manage. I mean, ultimately, there's nothing really different with event-driven versus, say, maybe synchronous request response or asynchronous request response, really. If you have a service that one team owns that exposes functionality to another team, that is your point of coordination. So we're trying to reduce coordination, but if you create a service that is used by other people, you do need to coordinate with those people. What is it that you need my service to do? What's the best way for me to create that API? So I see event-driven really is no different here. You want to be explicit about the services you expose. You want to make it easy for those people to use your service. I don't think there's anything special with event-driven architectures, to be honest with you. Do we get the slides in the talk? Yes. They're on my website. If you go to my website on the talk section, there's a section for this talk. You can get the slides there. I've made some slight tweaks to these slides, so I'll also make sure they're available via the Software Circus as well. So you will get access to these slides and a video recording. Yes. So the question was, even sort of business-focused features can sometimes impact lots and lots and lots of services. How do you deal with that? The first thing to say is that when you get those cross-cutting changes is it an exceptional activity or is it a rare activity? Sometimes these things just kind of happen. I was working with a fintech company recently that are really focused on like end-to-end product feature sets for this kind of flow. And it is one of the best organizations I've worked with in terms of really close alignment between the product owner and the business and the development teams. Everyone's really aware of what the customer wants. Every team owns a slice of the user interface, which I think is really important as well. Often that gets overlooked. They actually had to roll out multi-user access So basically, it's a financial account. I now need to allow more people to access the same account with controls. That's going to cut across everything. And what they actually have done in that particular situation is they created a dedicated team to roll out that feature. They're looking at it holistically, understanding what needs to change. They're going and coordinating with those teams to make that change. It will happen rarely. When it does happen, guess what? We've been dealing with dependencies in project management for about 4,000 years. You get a spreadsheet out, you do a Gantt chart. It's not the end of the world. If you're doing that on a daily basis, something's wrong. It will happen. And sometimes if it's like a new cross-cutting feature set, like the multi-user access, the answer can sometimes just be create a team to spearhead that change and get that put in. The challenge then becomes you've got a team that's focused on end-to-end delivery of their part of the feature set, but they're not, and they're sort of dimly aware they're supposed to be supporting this new cross-cutting change. You will also need someone potentially to advocate for it to make sure it gets right at the priority stack. And that was the biggest challenge that they were having. So, they had a product owner that was owning cross. The problem was the product owners that worked with the teams and had a whole delivery team themselves, they had a lot of control. The poor product owner that was owning sort of the multi-user access side of that was sort of having to fight with all the product owners. At that point, it becomes politics. And, again, I'm British, so I stay out of that stuff. Right. Okay. So I've answered that question. That was that one here. Do you think it's better to speak about business ownership than services ownership? I'm not as up on sort of products, the business and product ownership side and how those kind of companies structure themselves. I've always sort of driven change from the IT side up under, and so I don't feel as qualified to talk about some of those things. Fundamentally, all I'm reflecting on here is that proper technology companies realize they need to reduce barriers and remove handoffs. So that's kind of the limits of my experience here. If you want to know a bit more about some ideas, maybe about how you can kind of think about the alignment of product and IT and those sorts of things, there's some really good books. There's Melissa Perry's got a book called The Build Trap, which is well worth reading, which talks about sort of product development and how you shouldn't build things all the time. There's also the book The Lean Enterprise, which is very good. That's from O'Reilly as well, which is worth reading in that space. And what about the weak code ownership model? When you get down to it, the weak code ownership model, it doesn't really exist very much. Most times people end up being polarized in either the collective or the strong ownership models. Also, I've taken collective ownership from Martin's, Martin talked about collective ownership, weak ownership, and strong ownership as it relates to code really within a team. And I've applied those ideas at service level. And so there isn't really an equivalent of the sort of weak ownership model. Anyway, thank you for all your questions. I'm on the internet. You can send questions to me on the internet, and I will sometimes respond. So thank you for your time.